Hi, I'm going to demonstrate today so how we can use the LED as a blink, status information to the outside world. So let me talk about it. So we have different states in the in our embedded devices. So we need to communicate that okay, what is the current state we are in, where we don't have any other way to communicate other than a status LED. So this status LED can tell us based on number of blinks per second, okay, whether I'm in a good condition or I'm in a error state or I'm in a state where I'm doing some certain activity. So for that you need to set the blink rates, so based on the state at which the system is working on. So here there is no way, and there is no any other way to communicate to the outside world. So that is the reason we are going with this blink rate status. So in this task I am having a main function where I'm creating doing a system configuration, and then we're basically in system configuration, other than the the log config, we have only the one pin, which is a LED pin, which is LED pin GPI 1 number 2, which is a built-in LED on ESP32, and we are going to create a LED task which will blink number of times based on the user input via debug port. So let me go to the LED task which is defined here. So in the LED task, what we are considering is the default blink rate is 1, which means which blinks once in 1 second. So, and we are also considering the on time delay, off time delay. That means if you are going to blink for say 1 second once, so 500 millisecond is the on time, 500 millisecond is the off time. So this we can change, so based on your inputs. So I have made a provision for that as well in this program, so that I defined in LED blink task. So if I go here, you can see there are many other configurations. So what is LED on state, what is LED off state, and LED minimum blinks per second is set as 1, and maximum is set as 9. I think behind 9 blinks per second, where we cannot differentiate to the human human eye. So the LED on time delay, which is 30%, and LED off time delay, which is 70%. That means if you want to blink once in a second, so 30% of 1000 milliseconds is 300 milliseconds on time, 700 milliseconds off time. So if it is 2, then it will be adjusted accordingly, okay, that I'm going to print in here. So hope you understood the configurations for the LEDs. So let me go through. So we are entering into the loop, and we wait for the user to change the blink rate based on the his needs. So this we can expand it to any of the way you want it. I mean, right now I'm getting this input from the user because I want to show this demo in dynamically whenever you enter the values. Okay, now I wanted to show you that how the and this is handled. How we are calculating the blink delays. So we have taken the user input and getting within actually getting the event values. Simple way to convert the user input value, which is an ASCII to a number. So now because we are only using a one character, so there is no need of using any other way, any other complex mechanisms. So then I'm printing how much, what is the count we received, and then we are going here. If it is within the range, so then we take that to the blink count, and based on the blink count, So we calculate the on time delay, that is 1000 is 1 second, that is 1000 milliseconds into the percentage of on time. So that is 1000 into 300 divided by blink count. So how many times you want to blink in a second? So right now it is 1, so that means 1000. So then converting from percentage, so it is divided by 100. So finally you're going to get 300 out of this, and here it is 70 set by default, so it will be 700. So let's go, and then if say the user entered a 0, so that means you are not going to blink anything, so it is like turning off the LED. So this might help when your device is a you want to save some power. If it is a battery operated device and you want to save some power, and when there is a state change, so then only you're going to blink for some time, and then you're going to stop the blink after. Whenever there is a state change happens, you can blink for say 5-6 seconds. Okay, state changes happened, and then you can go turn off the LED so that you can save some power. So this is where I made a provision, so you can turn it off. Okay, and you're going to turn this off, and then every 1 second again you will keep on changing it. So if it is any invalid input, we are not going to do anything else. So whenever the blink count is not 0, then only we are looping around with on and off based on the on time and off time delays. Otherwise we keep it low and just stay there. I think hope you understood the flow of the program. I'm going for the demo section now. Okay, this is where the currently I'm running the project. So this is the ESP32 development kit. So let me start, compile and program this project. Okay, so now it is compiling. Okay, building in release mode, and the build is complete, and we are programming. You can see the LED stopped blinking, and right now we are programming, and programming successful. Now it is set to default values. So default values is 1 second blink, 500 on time, 500 millisecond on time, 500 millisecond off time. Okay, so now let me go. I think it's better for you to understand where is this. So now I'm going to say 1. I entered 1. Okay, till now that was not printing anything. So whenever I entered 1, it started calculating, and then the on time was 300 milliseconds and off time was 700 milliseconds, and it keeps printing the same, and you can change the blink rate. So I'm going to enter 2 now. You can see the blink rate is changed. On time is 150, off time is 350. So now I'm going to enter 3. It's again increased. So 100 is on time, 233 is off time. Okay, 4, 5, 6, 7, 8, 9, 0. Say 5, 1, 6, 9, 2, 0. Okay, this is the short demo. So you can use this module for any of your status LEDs indications. Thank you.